Hello! In this video tutorial I will show you how to develop your first artificial neural network in Keras. It is not intended to be a deep explanation of how the math behind Keras and the neural networks works. It's just going to show you how very simply in a few lines of code you can create a model that will achieve good results. So let's get started. First of all, what is Keras? Keras is a high-level API written in Python that allows you to create powerful deep learning models in a few lines of code. It works on top of the fast computational libraries like TensorFlow or Theano, and makes them very easy to use. Okay, let's get started. I'm just looking through my notes. Okay. First, we will need to import the libraries and load our data. We will need a few libraries, such as pandas, to browse our data and see what it's all about. NumPy for numerical computation. And that's it. We could also import matplotlib or Seaborn for data visualization, but I think we will keep it simple this time. So later we will also need scikit-learn for train and test, for splitting our data into train and test datasets. And the libraries we will need for Keras we will import later. So let's assume that this will be enough for now. In this tutorial we are going to use a classic dataset that is used to predict one set of diabetes based on diagnostic measures. You can find this dataset in the description of this video. I will just leave a link there, and you will need to download it and put it into the folder with the project, or in a separate data folder, and then you will need to be able to know the path to it, so you could load it. So to load our data, we will use a very simple command like this. Instead of, if you put the data into a separate data folder, you can do something like this, like go up a folder and go into data and load the diabetes file, or we can just put it into the folder with our project and do it like so. After that we can look at the first 5 rows of the data to understand what it's all about. As you can see, it has several columns. It has various measurements such as number of pregnancies, the glucose level, blood pressure, skin thickness, insulin, body mass index, and whatever this means, diabetes pedigree function, and also age. And final column will be our labels, that is the outcome. 1 means the person has developed diabetes in the next few years, and 0 means he didn't. Actually, it's exactly within 5 years of measurements. So our next goal is to prepare the data. Again, in this tutorial we will keep it very simple. All we need to do is to first select our features. In this case we will use pandas method drop. So this is a PD read CSV created a pandas table, and in a lot of ways, a lot like Excel, pandas allows you to very easily and conveniently modify the data and do all sorts of cool stuff with it. In this case, to create our features, that is the inputs we will use to predict the output, all we need to do is to get rid of the outcome column. We will just remove all this column, and that will result in our features. Here we type axis equals 1 to make sure that it removes the column. Otherwise it will try to remove one of the rows and fail. To create the labels variable, all we need to do is just take this outcome column. So we have our features, the input data, and labels the output data that we are going to try to predict. We will also set a default seed, like so that whenever we run this notebook again, we will be able to get the same results without much randomness. Excellent. So these are what our variables defined. And finally, we want to split data into a training and test set. Training set will be used to train our model, and test set will be used to evaluate it, to see how well it performs. So first we will set a test size to 33%, and then we will use the standard way to split train and test data using scikit-learn function, like so. Xtrain stands for training features, Y stands for labels, so training features, training testing features, training labels, and test labels. All it will do is take this whole table with many rows and set aside 33% of it into test data. The rest of it will remain in training variables. Here, this part of code defines the 4 variables, and this function returns them automatically based on the features that we provided, this line of code, the labels, this line of code, test size, that's our 33%, and random state, again, to avoid too much randomness. Let's run it. Speed. We can check out Xtrain size. Sorry. Xtrain describe will tell us all sorts of information about the data. So if you want to explore this dataset and understand all sorts of things about all sorts of parameters about it, we can see the average numbers of values of the variables, percentiles, minimal, maximum, standard deviation, etc. And the Y train describe will tell us about the outputs, and count tells us how many we have, how many data points we have. So time to create our first model. To do that, we will need to import so-called sequential model from Keras. Sequential basically means just a normal deep neural network. There are all sorts of neural networks, convolutional, recurrent, all sorts of crazy architectures, but sequential simply means several layers stacked on top of each other, processing information, like the simplest possible version of it. So I recommend using it as a default if you're not sure what else to use. To create this model, all we need to do is to call it and put it into a variable, like so. So the next thing that we need to do is to add several layers. Basically, Keras allows us to define an architecture of our model without going too deeply into math. We will just tell it what kind of layers we want to create, and it will create them for us. The normal fully connected deep neural network layer is called dense. That means all the neurons are connected to all the other neurons. So in our neural network, we we'll have two deep layers. Let's go ahead and start creating them right away. So we will import dense. So this is the default standard neural network layer. We will add it to our model. First we will add our first deep layer. It will have 8 inputs, one for each feature. So as you can see, we have several features, 8 of them, and we will input them into this layer. It will have 12 neurons. This parameter tells us how neurons it will have, and activation will be ReLU because it's a pretty standard way to start. Pretty standard function for an activation that tends to work well for most stuff. Now let's add one more layer. It will have 10 neurons, and create an output layer which will have an activation sigmoid, which is basically a probability distribution. You can look up the functions and how they look like on Google, but basically this one works best for deep layers, and this one for predicting probabilities, because we are trying to predict how likely is it for a person to develop diabetes. Sigmoid will work just fine for us. So this is all that's necessary to define our models. We have created it, a sequential model, and we have added 3 layers to it. The final thing that we need to do is to compile it. That will turn the Python code into a fast and well-performing code that works under the hood. So here we can define a few more parameters. The last function, like how it will calculate errors, the optimizer, how it will update the weights, and the metrics that it will display to us. So it will take a while. Our model will be compiled, and the final thing we need to do is to feed it. We need to pass it the data, train our features, our training features, our training labels, how many iterations it has to train for, they are called epochs, and batch size, how many iterations it has trained for before updating the weights. So after we run this code, it will think for a while and it will start training it. It will run through the network multiple times and look at the error rate and use it to update the weights of each neuron. It might take a while, but after it's done, it will return to us a very well trained neural network model that we will be able to use to predict things. While it's thinking, let me see what else I wanted to mention. Looking through my notes. Binary cross entropy. When you compile your artificial neural network, Keras is going to use either Tiana or TensorFlow, and you can and it will use it to optimally represent the network you have defined to make computation faster. And which one you want to choose, you can just set it in settings. Yeah, loss function determines what kind of function it's using for computing the error. Optimizing is an algorithm that tweaks the weights to gradually improve them. That's I already explained it. And yes, the accuracy, you can specify more than one metric, and it will this is the metrics that Keras will collect and report back to you. So as you can see, because we have a specified accuracy, it now shows us the accuracy and also the loss function here. So accuracy is like at the very first iteration, it is 38%, which is worse than random, I suppose. And then as it goes along, the accuracy keeps improving, and at the end of the day, the accuracy we have is 78%. Excellent. And by the way, it has already finished training. So the final step is to evaluate our results. To do that, we simply create a scores variable like so, and we type model evaluate and pass it the testing data. So that will take the test data that the model has never seen before and look at how successful it is at evaluating, at predicting the outcomes in new data. And then we will print the results. So we will print the first score, that is I suppose accuracy in percentage, like so. So the accuracy in the test situation is a bit lower than in training because there was a little bit of overfitting going on, but at the end of the day we have accuracy of 71%, which is pretty sweet if you ask me. That's a very basic, very simple, very fundamental way to create models in Keras. It's not optimized, of course there can be many things to do to improve the results, and I will be happy to share them with you in my future tutorials. And as I'm learning to get better at AI and machine learning and making videos, hopefully we will go deeper and understand what each of these lines of code mean more. But for now, I just wanted to point out how simple and easy it is to train a neural network. It takes like import several libraries, read the data, extract features and labels, split it with the function already written for us by scikit-learn. We can then just create a model. It took us like 1, 2, 3, 4 lines of code. Compile model to turn it into a fast and performant TensorFlow kind of thing, and finally feed it to automatically train it on our data. And to evaluate it, we just evaluate it. It's very fast, very simple, very easy to use. And there you go. I hope this video was useful to you. In the future, I really want to get deeper into the fundamentals and the math behind how it all works, what all of this means, what is ADAM, what is accuracy score, what is loss function. All of these fundamental concepts are something I would like to explain on this channel. But for now, I hope that was useful and fun and easy enough to follow. I'm thinking that I will also share this notebook. You will also find a link to it in the description of this video, and I'll see you in my future videos.